All right, so I'm gonna talk about a bunch of observability infrastructure stuff I'm working on. About
like 4 times the volume.
I'm gonna try and talk about some of the observability infrastructure things I'm trying to work on. I have a bunch of things in here that are kind of arranged in order of completeness, basically. A couple things at the start that have landed already. Gonna cover a bunch of things. Using syntax, the resource thing. Acyclical storage and diagnostics channel both have support for that now. It's mostly was added for internal use, but it is public. It can be used externally as well, but it eliminates a bunch of closures, so should make things a little faster. The interface looks like this. So there's with scope on async local storage returns usable scope that it'll set the store value for just that scope. And there's a new thing called bounded channel. Diagnostic channel has, like previously had just singular channels and then tracing channel, which was a bundle of a whole bunch of channels. And there was a bunch of confusion about what all of the different channels in a tracing channel meant. So there's like start and end, async start and async end, and an error channel. And there's a lot of confusion about people like misunderstanding async start as like when you make the call, but that's not what it actually is. It's when the continuation starts. They made this separate bounded channel concept, which is a reusable component, which it's basically just a pairing of a start and an end. And so there's one of these around the call and then another of these around the continuation, and they just get like it's just constructed with a different set of channels for each situation. These channels now also support the scoping mechanism. So the existing bind store, you can use that to map a channel event into an async local storage store. Now you can use the with store scope to do that within just a synchronous scope rather than needing to wrap closures around everything. So it simplifies things somewhat. Next up is I'm working on this metrics interface, which is somewhat inspired by like how diagnostics channel works, but in like trying to combine that with typical metrics interfaces and trying to enable. So the metrics landscape has kind of two very different models. That there's like Prometheus, which is a pull model, and then there's like OpenTelemetry as a push model. And so I put a bunch of work into trying to figure out how to get both things to fit into the same model, which I think I've done a reasonable job of. So at the moment, this just has a generic metrics object that you create. It's not explicitly typed. You can just give it a type as like an attribute right now. I'll probably add a like higher level like helper thing on top of this at some point, but just want to like the PR is already like 8,000 lines or something, or like I think like 8,000 lines of code. So I don't want to make it too much bigger. The concept is you just have a metrics object which you record just singular values into, and it doesn't necessarily enforce any particular meaning on what that value is. That happens at the other end of the pipeline. So you can do things like, for example, say you're like measuring HTTP request times. You may want to do that in the way of, I want to compute how much time is spent in all requests over some window, in which case you want the cumulative value. Or you might want to figure out, oh, what's the average request time over this window? Or like there's lots of different expressions that you might want from the same sort of piece of data. And so I'm trying to not impose that on the publishing side. I'm just publishing, here's a piece of data, it represents this. And so for the timer scenario specifically, we do have a little extra sugar just because it was easy to add. It's another scope thing. You start a timer and it stops when it completes, and that's just doing the metrics record internally. There's like pull-based function metrics. So for things like process memory usage, that's not going to give you like an event on its own. You have to call it, and so the pull interface has this callback thing that it will pull from this interface. So whenever the collection process happens on the other end, it will trigger any of these pull style metrics and retrieve whatever it needs to. So this is the consumer side of it. So you create a consumer and you specify all of the named metrics that you're interested in. And for each of them, you give it a configuration describing what you want to do with that metric. So like how you aggregate this, like the sequence of values into whatever you want the ultimate value to be. So like you can make it a histogram, you can make it a sum, you can do whatever you want. And it has these two different collection methods. So you can directly call the collect. So if you're using Prometheus, you can just call collect to pull whatever is in the consumer since the last time you collected. Or if you want to do like a periodic style push, you just do the auto collect on whatever timer, or like you can build your own thing around the collect if you want to do some other triggering mechanism. But essentially the concept is that between collect calls, it will accumulate everything inside of this consumer based on the aggregation configuration. And there's also multi-tenant, so you can have like any number of consumers. So if you have like multiple observability products that are both interested in metrics in different ways, they can consume different sets of metrics, different configurations of how they want to aggregate it, all this sort of stuff. Another thing is composable tracing channels. The bounded channel thing was the start of this, and that's landed already. So at the moment we have tracing channel, which has like trace sync, trace callback, and trace promise all kind of mashed into one object, and it's just trying to express every possible type of tracing of a thing that we would want to do. But there's just too many things that don't fit into that, and it's not very composable. So there's a lot of situations where code just does different things that don't fit super well. Like you sometimes see libraries where it like will take a callback, but if you don't give it a callback, it returns a promise instead. So you have to trace it in like two different ways depending on how it was called. There's like now with all the like AI SDK stuff, there's a lot of libraries that are now like returning like async iterators, and we didn't have any solution for that before. So we needed a way to properly instrument async iterators as well. So the way I decided to think about this is there's really actually three categories of things that we need to trace. There's a call of a function. There's input parameters like callbacks. We need to trace the callback when it happens, and that comes in from the input. And we need to trace things from return values like promises. Once we get the promise, then we attach something to listen to when it resolves. Once we receive an iterator of some variety, we attach whatever tracing we need to trace that. So this is an example of composing them all. So the basic tracing channel, that should actually be the sync tracing channel. But yeah, there's so the sync tracing channel has a wrap function which traces just the call itself, but it can also take this options object to add additional wrappers to do some like branching logic. So like this will also patch a callback being passed into this, and can also patch a return value as well. So this can handle the like both callback and promise pattern and things like that. See, the next thing I want to talk about is the concept of lightweight spans. So Brian did a little bit with his OpenTelemetry PR. This point is kind of where I don't have things, like I don't have PRs open for the rest of this. But this is kind of stuff that's floating around in my head and I want to do something with. And the rest of this, I kind of want to talk with the room a little more about it. So lightweight spans. So I've kind of looked around at some other languages and seen like interesting stuff that they do. So like Swift actually does a pretty interesting thing that's they actually have three separate libraries. There's Swift distributed tracing, gives you not much more than just this with span function, which you just create spans, and in the background, Swift will just figure out how to propagate that. It has a, well, it like task local storage essentially. It's pretty much the same sort of things are async local storage, but not exposed as an object in the same way. But they have this span construction mechanism that any library anywhere can just create a span. It doesn't need to care who's going to do anything with it. It just creates it, adds some attributes to it, and it's like, yep, something might care about this, so I'm going to do this, and then it continues on. Rust also has a similar thing with the tracing crate. That what the tracing crate does is a little bit different from other things I've seen. That it kind of combines the concept of spans with the concept of logging. So the framework actually has like it's a whole logging framework, but then you can create span objects as log events with their own log level within that. It's a little bit different, but yeah, there's just ideas from these that I was thinking about what we can do with that. So this is kind of just some like ideation on what a like equivalent in Node could look like. Just have like a span function that takes a name and some attributes, and it returns like a scope object, and that can just trigger like diagnostics channel events in the background. Exactly what those are is at the moment still unclear, but just kind of thinking about the general idea. I see a hand raised.
I can ask a question after you finish.
Sure. Yeah. So trying to go for being as open telemetry capable as possible, hopefully. So just kind of thinking of like what interfaces are needed on such a thing to be able to align with that, while not necessarily being open telemetry specific. But yeah, just these are kind of the ideas of what I've thought about so far, but others might have more input on that. And the last idea, this one's much more of a question mark. So, well, there's the OTel effort from Brian already that's was doing the like OTLP as JSON approach, which is like that's reasonable, I think, from the JavaScript sourced data. But another problem that we have is profiling, where the profiler is all like native C++ side and has to ship all of the profiling data to the JavaScript side somehow. What V8 gives you is a large graph object, which if you walk that, like if you expose that to JavaScript and then try to walk that tree in JavaScript, you're crossing the barrier like tens of thousands of times. And it's just very complicated. Like it will cause a huge latency spike if you try to do that. So what I wanted to do was to have some way to like just binary encode that from the native side. So I was experimenting a bit with the idea of just having a simplified protobuf encoder in core, because the amount of protobuf that OTLP actually uses is actually a very limited slice. So you can actually discard like 90% of what protobuf does, and just like I have a thing that covers pretty much the entire spec in C right now, and it's like 5,000 lines, I think, of like one file. Yeah. But yeah, the other possibility is like the native side could theoretically encode JSON as well, but I don't know if we have a good way to do that either from the native side. So yeah, good hand roll protobuf. It's not completely absurd, is it? Yeah, this is just kind of a look at what I have right now, like what it looks like. There's like a C API and then like a C++ wrapper API over top of it. Just create logs and stuff. Yeah, there's some other parts that I didn't get into here. I was just kind of making these slides earlier. Anyways, that's kind of the direction I'm going in right now. Anyone else have thoughts on it? Opinions? Well, I think you had your hand up like much earlier.
My question is more about the previous the overall. My question is more about the overall optometry overlap, especially given the context that we are going to bring in the optometry building supporting the Node.js brought up by Brian in the pull request. Not specifically to this slide. I'm not sure if Brian wants to talk about this slide.
Yeah. So I'm mostly just trying to think what the ideas here are not necessarily trying to say that like the pull requests that are open now, or I guess you closed your PR before, but It's not any evaluation that's like what is out there right now is wrong or anything. So much as just trying to figure out exactly what we need and if the existing things align, what we should expose separately, if we should have interfaces that can be used in a way that like what Brian provided before was like there is a span interface that talks directly to OpenTelemetry, and that's basically it. But do we want a thing that we can talk to that and it could talk to OpenTelemetry or it could talk to other things? Can we make something that is more generic like that? Should we?
Feels like we're kind of piling abstract layers on top of abstract layers, though. Because as far as I understood from Chengzhong's talk, the OpenTelemetry SDK was meant to be abstract.
I mean, yes and no. Brian, do you want to say anything?
So a couple of things. First of all, to address your open question here, like I think the answer is like probably fairly obvious, and that is wherever we're exporting data, if we're doing it from that layer relatively directly, there's no reason that we have to pick one answer, right? And like I think it's reasonable to just pick the best answer for each of these. Like if you're in profiling, you're in native, let's do the most appropriate answer there, and so on.
Okay.
As for how the lightweight spans would interact with, for example, my PR for OpenTelemetry support, they're almost tangential, right? Because what you're proposing, Stephen, is just an interface for creating spans.
Yeah.
And with the entire back end of it being up in the air, more or less, right?
Yeah.
So that back end could be the approach that I was taking in my PR, or some evolution of it. It could be something else entirely. Somebody could just want to log things and that's it. It could go straight to an OpenTelemetry SDK directly. It could be anything. So I think like making sure that no matter which approach is taken is as pluggable as the kind of thing you're suggesting, Stephen. I think it's all correct.
Yeah, I'm not sure if I understand Stephen's slides correctly, because the previous slides were proposing like new Node.js building modules like node column metrics and node column tracing. And let's say if we took Brian's pull request in, we will have node hotel or OpenTelemetry for the full name. And eventually I'm trying to imagine what the future looks like. I would feel like we will have 3 building modules that are built on the same scope, and it will be like, I don't think that would be intuitive for user to pick between 3 of these and how to produce their data.
I definitely don't think we should have like multiple implementations of things. Just we have a bunch of work that has started and nothing has been accepted yet, and so I'm trying to figure out like what is the thing that's going to work the best for everyone.
There's also no reason they all can't just be under some generic observability module or something like that. We could do whatever we want here. It certainly doesn't have to be 3 modules.
Yeah. So I think my idea was that how, like say, if we are going to propose new APIs in API layers in the Node.js, and if we are going to integrate OpenTelemetry API, specifically API somewhat in the Node.js, we are not going to, like say, if we are not going to integrate the SDK or any exporters in the Node.js, but I think we are also covering exporters here in the OTLP protocol. But like say, let's focus on the API now. So I think given that the massive adoption in the ecosystem, and how are we going to add the API layer in the Node.js to cooperate with this massive adoption? I think that would be the question for us to add any of these APIs in this observability scope in the Node.js.
Yeah, one thing that I think is worth thinking about. So like in a lot of languages, they have either directly in core or in like official ecosystem created their own like basic span systems, which are not directly what OpenTelemetry does, but OpenTelemetry layers on top of all of these. So like OpenTelemetry has Swift support and they use this. They have Rust support and they use this.
Yeah.
So, like I feel like having several languages that are doing this thing already indicates that we should probably be.
I think we have to take
define a layer that is like the minimal requirements to fit in Node Core without having a ton of other stuff needed, and then just making sure that OpenTelemetry can layer over that effectively.
I think we have to take the like timeline, how the history was developed around this work. Like OpenTelemetry was established in 2019, and the Trace API was stable since 2021 probably, and Metrics was in 2023 also. And you can see that there are non-trivial work in OpenTelemetry to make the vendor neutral work stable. And this language and this API in other languages, they were mostly pre-OpenTelemetry era. So I don't think in Node.js at this moment right now, it'll be like say, I think the question is for the rest of the Node.js contributors, are we going to reinvest all of this effort in this place with OpenTelemetry already stable at the moment and have been already adopted by all the vendors already? I think that's a question for us.
But both Swift and Rust themselves did indeed exist before OpenTelemetry did, but neither of these span solutions existed before OpenTelemetry. Like, but both of these happened after OpenTelemetry was already in relatively wide use, and then they just layered on top of these.
I guess it's kind of a, you need a crystal ball to predict whether the OpenTelemetry concepts and vocabulary are likely to become de facto standard. Because I think it does create a little bit of cognitive overhead when you have a language specific set of concepts and vocabulary that are behind the scenes using, connected to something else with slightly different vocabulary. If people are increasingly confident that OTel is the way, then that makes a stronger case that we should just travel in terms of OTel concepts and vocabulary. But are we there yet? I don't know.
That's why I went for like describing the like API as similarly as I could, to just like I want to align with the parts of OpenTelemetry that I think people generally agree are good and useful. There are a bunch of like extra parts, like the tracer provider, like making a tracer and then that making a span, is very much a OpenTelemetry brained way of doing things, and like none of the other tracers do that. None of the like observability providers do that in their own systems. Like there are a bunch of aspects of OpenTelemetry which they're fine, I guess, but like we don't necessarily even need those. Like all of that can be internal implementation detail. Like you don't need to be operating that directly. We don't need to support that directly. We can just emit the span data and have OpenTelemetry externally listen to that, as long as the data itself follows. So like if we follow like semantic conventions and we are producing spans that have like the same core sets of interfaces on the spans, there's not actually anything more than that open telemetry actually needs.
So regarding the trace provider and similar concept in OpenTelemetry, I think that's more about like instrumentation scope or something like that. These were designed to be like debug information, like who generated this instrumentation, like trace span, and who generated like a particular metric counter. Like we don't necessarily to have to export this data into the data backend. They can be just used at the front end to debug who actually generated this data and what's their version of the library that generates the data. And we can say that we don't need this debug information. Well, that's fine. But for the instrumentation library, especially given that there are more and more libraries are going to generate like spans data, metrics data, we need some like guardrail for people to actually debug what's going on in this data being generated if they found something wrong with this data. So I think OpenTelemetry can definitely like provide a default trace providers to like reduce the boilerplates to like create a span that's I mean that's doable in OpenTelemetry. There's nothing I don't think that's say impossible. So that still comes to the question, like if we are going to align the like assuming a Node.js building new API layer on the tracing, and we are going to align it with the OpenTelemetry, and what's the end story would be this API like? Are we going to like mimicking every OpenTelemetry API in this case in the end? So I think it's still unclear to me how are we going to address the overlapping issue here.
Like none of the things like resource or instrumentation scope are things that this is unable to capture. Like you can still capture that perfectly fine, just have a different interface for capturing that. Like the like tracer provider, tracer span hierarchy thing is one possible way to capture that. You don't have to capture it in that particular way. There's lots of ways we could do this, and there's like ways that we could do it which provide like more of like default configurations, which it does not do. Like with Brian's PR before, like he was capturing like the resource in the background, which like you can infer that from like pulling stuff out of the package JSON and things like that. And then have like if you really want, you can have an interface to like override that, but that doesn't have to be part of an object hierarchy that's like, oh yeah, I have to go through this to get to this thing. Like that's way overcomplicated. Like just have a function that makes a span. You don't need more than that.
I think that's more about the discussion how on the implementation detail, how are we going to get the debug information? Like OpenTelemetry was originally designed to be a thin API layer, and the SDK were designed to do purely the generating and consuming the data. It can read the package.json, but I mean, should it? You can just write your own code and provide it directly, right? So OpenTelemetry can potentially read the package.json, but I'm not sure that's a good way. Like I need to walk back to the code stack and to get who code the OpenTelemetry API and then read their package.json. I feel like that's pretty much
like,
out of the line.
We don't have to do that. I'm just saying that that's a thing we can do. But like the other PR was doing essentially that sort of thing. Like like there's a lot of possible ways that like the resource or the instrumentation scope could be captured. Like we don't need to follow like one extremely specific way to do all of this. Like all of the same data can be captured. All of the same data can be like made available to process in whatever way you want. There's nothing in this that OpenTelemetry could not fully use.
I'm not sure if the discussion is coming to an closing end at the moment. Maybe we can yield to other questions if there are any.
Continuing. All right, I think just continuing a little bit on what we talked about now with instrumentation scope and the whole tracer sub-level in between. So if I understand correctly, the API as it's proposed here would, if implemented, we would just use that in OpenTelemetry, right? So for example, implementing a tracer provider that for starting a span on the tracer would just use that API. And if we want to layer stuff on top, like the instrumentation scope, for example, we would still go through our normal APIs, keep that in mind, and then stitch that together later. Is that the kind of envisioned approach for this one?
Yeah, so the my intention with this like particular API is to just have a thing in core that we can provide for people to say, I want to create a span, and that's it. Have no opinion of what's happening with that span. It is just here's a bunch of data. Something might care about this. OpenTelemetry can then listen to whatever the other side of this is. Like my expectation is this would probably go into diagnostics channels in some form. That's not defined yet, but OpenTelemetry would listen to something and use that to create your own spans from this data.
Right. Okay. Thank you.
So, Stephen, can I just ask, do you expect that end user code would bother with an OpenTelemetry specific API, or just use this in-core API directly and have OTel on the receiving end of it?
Have OTel on the receiving end, essentially. Like my thinking is just to have a generic way that like it like if they want to like go and use the OpenTelemetry API module, like there's nothing stopping them from doing that. Just like,
but I guess to avoid beating around the bush, like the OpenTelemetry SDK API is kind of like redundant with this, right? Is that fair to say?
Not exactly. Like the intent with this is more just to have a thing in core that like at the moment libraries have to either rely on the OpenTelemetry API module directly, which is tying their module directly to OpenTelemetry specifically, or if we have a thing like this, they can just use this thing because it would theoretically already be in core. So any library could just go and call this thing, and yeah, it could be sending to OpenTelemetry, or it could be sending to who knows what else. But like other observability vendors could listen to this directly if they wanted to, and not go through OpenTelemetry at all, if that's what they wanted to do. Like the idea is for this to be completely detached from any sort of like processing system in the background. It is just a way to say, hey, I have some data. But like OpenTelemetry, you can use it if you want to, and like if some end user specifically wants to be using OpenTelemetry, they can go ahead and do that. So like I don't think they're in conflict or.
But I mean, I think if someone has a library, let's say that and like today, they want to use that they're anticipating its usage in Node.js, they might use this API, and then if they want to make it work in a browser, they're going to have to port it to something else anyway, because this API is not going to be usable in any other context, right?
Well, like the idea of this is for it to like not have any specific backend. So like you could fairly trivially port it to the browser as well if you want to.
I think at the point that somebody's ported this API to a browser for, as I said, generic library code, then we've got to give it a name, and it's effectively competing with the OpenTelemetry SDK, right? Which is fine. Maybe we've got a reason to think it's better, but
I really don't think of it as a competing thing. I think of it like OpenTelemetry is the processing engine and like the system of sending stuff to places, all the sampling, all of that stuff. This doesn't do any of that. It has no opinion of that. It is just an interface to say, I have some data, which yes, OpenTelemetry has a small piece of itself that is that. But
I see. Okay, I get your point.
That piece of OpenTelemetry is tied specifically to OpenTelemetry and is not useful to say, I have a piece of data that is not for OpenTelemetry.
It's almost like you're making the case that the OpenTelemetry SDK should be split into two halves.
I mean, that would be a reasonable idea as well, I think.
Okay, that makes sense. Thanks.
Yeah, I'm not tied to this API design specifically. This is just me presenting an idea. It's mostly just about trying to come up with systems that are more generally useful and not tightly coupled like those systems are.
Yeah, I guess with the OpenTelemetry SDK, as far as I understand it, it's not tightly coupled to an APM, definitely. But it does more than just provide the collection API.
Yeah.
Diving into this question, first, quick clarification. The OpenTelemetry API does the production of the data, and the SDK is just a consumer. And regarding, let's say, let's dive into this proposed API directly and avoiding the OpenTelemetry at all. But I think we have still to consider the design principle of the API on the observability scope. One of the reasons that OpenTelemetry was designed was that it provides a vendor-neutral API that the API could produce the data and the data flow that can be equally and balanced consumed by like every backend, and that's why all the vendors are like working on the OpenTelemetry and like supporting the OpenTelemetry data. And let's say if we are really going to do this in Node.js, Node.js as a open project, I think we should also adopt the neutrality on the API design that the data produced by this API could be reasonably consumed by all the backends and does not like say exposing a certain feature that's only exclusive to certain backends. And if we navigate back to for example, the node metrics pages on the probably previous pages, I think. Thank you. Right. So let's say, for example, this page. the reason that OpenTelemetry designed the API that, for example, it will allow users to create a counter, a histogram, or a observable with concrete API interfaces was that it provides a guardrail to users that their data being produced with the metrics can be equally consumed by all the backend. For example, a counter cannot be decremented in any way in the Prometheus backend. And if we say decreate a counter and feed that data to Prometheus, your data will be invalid and the whole timeline will be resetted. So the data will be inaccurate. I don't think that will be equal to Prometheus, which is the biggest backend for metrics data. The monotonicity might not matter for some backends. I think this creates inequality between the consumption of the data being produced by the API. So my point is that designing a observability API is not trivial. There are a lot of considerations to create a API that could be balanced and equally consumed by every backend vendors. So
yeah. Like I stated earlier, it's already my intent to create the types like counters and things like that on top of this. It just doesn't exist yet. I don't want to make the PR much bigger than it already is. But yes, we should have specific types on top of it to have guardrails to point in certain directions. But we can build the lower level system that is just the pipeline, which is what this is trying to be. And same as the other span interface that is being proposed. It's just trying to be the lower level pipeline system. It just takes some data and passes it along. And you can layer on top of that or underneath it however you want.
Well, it sounds like so this still sounds like we are reproducing all the work in OpenTelemetry in Node.js.
That was kind of my thought as well.
Just landing OpenTelemetry itself though doesn't really make sense because it is its own entire thing, and it only supports OpenTelemetry. Well, there's a bunch of other possible things that people would want to send data to, and so having a generic thing is the better option. Yeah. We can make the generic thing look fairly close to how OpenTelemetry functions, as long as that thing can actually produce data for other things. OpenTelemetry can't do that.
So I'm still a little bit confused, or maybe you can clarify that. What's the generic part that you think that is missing in OpenTelemetry?
The OpenTelemetry API is designed very specifically for how OpenTelemetry thinks about the construction of spans, the life cycle of spans. You deal with span objects. You don't do things with this API. Each of these functions could just be emitting events to individual channels for each of these functions that could be consumed and streamed out somewhere. OpenTelemetry can't do that.
I think
there's a lot more possibility by not defining what is underneath the system, whereas what OpenTelemetry provides is very, very structured and has a very specific expression of how spans work, which is actually quite inefficient in a bunch of ways, but it's what the industry is relatively widely adopted, that doesn't make it good.
I think we already made it clear that OpenTelemetry API yesterday that OpenTelemetry API was just a event dispatcher, like exactly like what you described. OpenTelemetry API does not allow you to retrieve any data that you feed into OpenTelemetry API. So you can implement a OpenTelemetry SDK that stream all the data out and does not store it in the memory. OpenTelemetry API does not care at all about this. And
you can
the
actually build your own
OTLP
separate like copy of what the API is, but you can't directly using the OpenTelemetry API like module itself. It has its own expression of how things flow through it.
There are guardrails that OpenTelemetry set to ensure that the data can be consumed by all the backends. That's the guardrail. I'm not sure what exact the event or life cycle that cannot be specifically supported by the current OpenTelemetry API, not the SDK, because the API is just an event dispatcher. And I think even if I ask in the PR or ask on just now,
like there's a bunch of things like it being deeply tied to the OpenTelemetry concept. Like you have to interact with the span context objects and all that sort of thing, which like most every APM separately from OpenTelemetry manages that in the background. You don't need to pass that through explicitly. And like there's a lot of these aspects like that where like it is very difficult to be able to pass your own context because the API has its own opinion of what a context is supposed to look like. There's like
the OpenTelemetry context is implemented on top of async local storage in Node.js. So you can just like say set it in the async local storage and being passed implicitly. So just like every other APM could do.
OpenTelemetry doesn't give you access to the async local storage. Like you can't do that.
Yeah, because as a library, as an API library, you don't want anyone to tamper the internal states directly. You have to follow the API guardrail to ensure that you are doing the correct thing.
But as an instrumenter, we often do need access to that.
Well, if every vendor wants that, you should come to OpenTelemetry. It's an open source project anyway.
I have come to them and nothing has happened on it.
There are certain, for example, OpenTelemetry also has to support the web browser. So we also have to ensure that the API is usable on the web browser. And we are pursuing to standardize the async local storage on the to be standardized in the JavaScript language. So I think there are recent works by Mark to allow flexible context manipulation recently. Maybe Mark can chime in more on that. But what my point is that OpenTelemetry is a open source project, and if say every vendor think that there are some shortcomings in the OpenTelemetry, it can definitely be done in OpenTelemetry. I think coming back to the original question, say, I'm still unclear that if the end game of this is to replicate every OpenTelemetry work in Node.js.
No, like I said before, the only thing we want to have is an interface to just say, here's some data. Like we don't want to do anything with that data. We want to leave that open-ended for whoever wants to consume it to decide how they want to deal with it.
Yes, but
OpenTelemetry can be one of those consumers. There could be many other different shapes of consumers that have completely different constraints from what you have. trying to align like every little detail to match the constraints that OpenTelemetry has, which aren't relevant in Node in a lot of the cases, doesn't really make sense.
Yes, like I mentioned, OpenTelemetry as a project, open source project, and open project, it has to ensure that it can be consumed by every backend. And if we want to do it in Node.js, we should also ensure that the data produced by Node.js can equally consumed by every backend. We can say that every backend has unique requirements on the data, and that's the baseline that OpenTelemetry defines. And if we want to ensure that the data can be consumed by backend in the Node.js, we have to overcome all of these unique requirements by all the backends as well in Node.js. So I'm still unsure that what the motivation is going to be different here.
Well, like all none of that actually matters because like this is not trying to deal with the backend in any way. This is just like it's literally just here's some data, do something with it. That can be handed to OpenTelemetry. It can decide how it's going to deal with passing this along to a backend. Something else can do the same thing. Like the only reason for this to exist separate from OpenTelemetry is that it is an API that is not tied to OpenTelemetry.
But sorry, I think the point is that the OpenTelemetry API is also not tied to OpenTelemetry. It's just this API that you're seeing on the screen, more or less, right? It's just spelled arbitrarily different.
It is somewhat tied to OpenTelemetry though. Like I mentioned,
but sorry, let me be clear. It's tied to OpenTelemetry because it's meant to support basically all the popular backends. So I think what James was trying to say is that if you have the same goal, you're going to end up with the same constraints. You might have there might be, the OpenTelemetry API might appear opinionated. Some of those opinions are specifically the result of allowing it to work with any backend. But some of them are just things that can be debated, and it's, as he says, as an open source project, we can improve the API, right?
I mean, there's a lot that I would disagree with that about. OpenTelemetry is like it's often described to me as being like vendor neutral, but that is only the case because they made every vendor look the same. Like it very much is an opinionated API. It has a very specific way of doing things.
But is that not the way that this is going to go as well? Especially once you've layered on the higher level typed metrics and things like that. The higher level metrics that you're able to provide are going to be constrained by what is implementable in Prometheus, for example.
Well, I'm trying as much as I can to steer away from that, because like I want for the interfaces to be as generally useful as possible, not to tie it to anything specific like that.
Also, just heads up, we've had two people raising their hands for like 10 minutes, 20 minutes.
Well, okay, I mean, I'm the next one, and I'm one of the probably only people who can speak a little bit to like the use case you're trying to serve here, because we don't use any of the APM vendors, right? We have our own. What you've presented though is like almost exactly our internal API, which obviously I appreciate, because it's like, oh, that's very familiar and we could probably migrate to it really easily. Unfortunately, my teammate who investigated whether we should look at adopting OpenTelemetry is not available. I can't pick her brain on it right now to give any feedback, but I do know she chose not to go with it. Take that for what you will, but I think there is definitely some space for not taking opinions in the platform level. So if it was to say we would never land an API like this because that is the job of libraries, that to me would be a reasonable place. But I don't think that if we are going to adopt something, that it should take opinions that might make sense for OpenTelemetry, because there will be people who are off right? And that's the whole point of genericizing something to, or abstracting it and taking away those opinions for the platform side, right? Like do what you want in the libraries, do what you want at an APM vendor. But like, if you're going to land something in Node Core, like it probably does need to serve this like weird one-off, use case that we have that is like our, bespoke internal backend. And I'm sure that exists somewhere else, not just us, but,
I think a quick
I
clarification here is
anecdotally
that
know of at least 10 companies that have built their own internal APMs like that because they don't like any of the existing things.
You're in the building of one of them. We have our own as well.
okay, cool.
Yeah.
I'm not the only one. Good. Yay.
a quick clarification here is that OpenTelemetry is not a platform. It does not provide any data storage. That's intentional design. And the reason is that OpenTelemetry deliberately leave the data storage to all the vendors because they are essentially the cloud providers.
Right, but my point here is we have our own clients, we have our own instrumentation layers, we don't use the open telemetry libraries in any form in this and have other opinions. But those opinions actually seem like at surface level that they would work with this API when the subject matter expert here, again, I'm not that person, so I'm not going to speak to specifics, but did assess using open telemetry in our use case and decided it was not a good fit. So,
But what does it mean to use OpenTelemetry there? Use OTLP or use the API, the constrained guardrails API?
I was specifically thinking the constrained guardrails piece. I think we do have some things that have tried to conform to the, I think I was loud enough to hear, but okay, but so for our tracing implementation, I am pretty sure we are actually following the OpenTelemetry API, but with, oh man, I was not prepared to speak on exactly what it was, but I was thinking more of the metric side. So to be clear, we have separate implementations here for those two, and our metrics backend is fully custom, and so does not conform to the OpenTelemetry API, nor does it conform to Prometheus or any of these other existing popular open source things. And so I'm assuming maybe Bloomberg has a similar situation where it's sort of a mixed bag. So what I was specifically saying is we chose not to use the libraries provided by the Open Telemetry project because they did not look like a viable option for the surface area we had to support. Does that answer that?
Yeah. So just to sort of clarify your use case, it sounds like the API is important because you want to get the most out of it that is most applicable to your applications and so on. But what's more important is the back end to that API, right?
Well, that's what drives the decisions in some of the front end part, right? Is like they were designed to work together well.
Sure, but like for example, if we have OpenTelemetry/API being provided by something, or this API or whatever, as long as you have a backend for that you get to implement, you're basically fine. Like again, you said you couldn't speak to the details here, but it sounds like that might be the case. Or maybe in the Bloomberg case, does that seem like that's the case?
I mean, we have superficially it looks isomorphic. Obviously it's not the exact same methods and vocabulary, but very similar.
Yeah, that's superficially is what. Yeah, I agree. That seems.
Yeah, I think something that I'm sort of missing is exactly what value does this unlock as a Node core API versus sort of user land thing. So I think that the analogy with Rust is that the Rust spans are in a crate, so it's not exactly core. It could be swapped out to something else. And so I think it feels on the surface like this API is essentially mimics OpenTelemetry. Maybe it's slightly different or not, but it's still an investment that Node.js needs to make to build it. So I guess I'm kind of wondering like what does it unlock that you couldn't do with an OpenTelemetry SDK today because it's in Node core?
So it couldn't be used for instrumenting Node core itself. It can be exposed to allow libraries to instrument their own code without having any specific dependencies on things. Like the OpenTelemetry API dependency is relatively small, but libraries may or may not want to depend on that. Like, while the OpenTelemetry API library is not huge, it on its own is bigger than a lot of libraries out there that we actually might want to instrument. And like having a dependency that doubles the size of your package is not a thing that a lot of people like.
Well, I mean, what about just doing what we did with Indici and just including it?
I mean, we tried to do that once before, and there was fairly visceral rejection to it. People did not want to have it in core. I don't. Maybe people are more receptive to having OpenTelemetry itself in core now. I don't know. I'm just presenting this as a possible solution for.
To be specific, just the API part, not the SDK part.
I mean, I don't know. Like we could, but like as I was saying before, though, like it still is very much tied specifically to OpenTelemetry. Like it is designed for that specific use case. Like it would be nice to have a thing that is more generic, more broadly useful. And that's kind of why I'm just like presenting this thing right now in front of all these people and not submitting a pull request for this right now, because like this is an idea right now. It is not like this is how it should be. I'm going to tell you all to land this now. I'm trying to talk to people about it and gather feedback and try to figure out like what exactly would the best general purpose API be. Like maybe it is OpenTelemetry API. I don't know.
Because I think it seems to me like the hypothesis is if Node.js builds this in, we'll get module authors to adopt it, and they would prefer this above an OpenTelemetry SDK or building OpenTelemetry tracers. So it seems like that's sort of what the decision would land on, is like, would we get that kind of adoption? Because if we do, then there's enough value. But if we don't, then maybe there's not.
Yeah, it's mostly just to simplify the case. So right now we have diagnostics channel and tracing channel, which a bunch of libraries have started to adopt, but it's like it is a more complicated, less obvious system for that use case. If all you want is explicitly, I just want to make some spans, then having a thing that is very clearly just doing only that, I think is beneficial to module authors. Like diagnostic channel gets you a bunch more flexibility if you want that extra flexibility, but you don't necessarily need to have that. It's helpful, but like there's kind of a case where like there are layers of flexibility benefits. Like some modules might only want just basic spans. Some might want, oh, I actually want like a full event stream on this and to have my own custom events and all sorts of things like that. There are benefits for many different levels.
If there's a case that diagnostics channel is a useful intermediary for dispatching this data, then maybe we should make that, into the OpenTelemetry project for the Node.js library at least.
I'm not sure what you mean.
As far as I understand it, your claim that the use of diagnostics channel adds value to this design. Is that correct?
Well, it is like the span interface. Like it is like one possible backend behind it potentially.
Okay, so it's not coupled. Okay.
I haven't defined what serves this yet. I'm just trying to present a possibility that like diagnostic channel could be the thing that this produces, but who knows what.
Yeah, I like the generic API.
Yeah, I think it's turned off.
I like the generic API a lot, and I am very like, I don't know. I get worried about us integrating systems that could change in the future. Like OpenTel might not be the cool thing that everyone's using in 10 years. And that's like the legacy that we have to maintain with Node is what are people going to be using and how do we set ourselves up for like long-term stability and how do we give the next OpenTel tools to build themselves up. And so I think having an abstracted or like a lower level, more node native system totally makes sense. And I like this proposal a lot. So.
Mark, stand up.
I just wanted to add one thing, and Shengshong has mentioned that before already. I feel like the problem that this is trying to solve is like it's exactly why OpenTelemetry was founded. Is probably if you look into some document on the community repo, there's probably some statement that says what is our mission, and it will very likely be exactly what you're looking for there. So it being an open source project and it also being available to suggest changes or to drive changes there, I think is something that should be taken into consideration when looking into making changes like this to the runtime. That's not to say that I think the changes are not valuable, because I think there's a lot of good stuff that can come from that. Handing off some of the work that's being done in the hotel SDKs to the runtime just opens up a lot more possibility for performance improvements. So I think that's something that we all want. But I think at the same point, the idea that OpenTelemetry cannot change and cannot move forward to accommodate these requirements might not be entirely true. So that's just my 2 cents on that topic.
I don't think that like OpenTelemetry can't change or things like that, and like I said, it might be the right thing to take OpenTelemetry API itself, and like maybe we would need to like work together to make appropriate changes for it to fit into Node Core. I don't know. Like the whole point of this conversation is just to try and think about what do spans in Node Core look like? Is it OpenTelemetry spans? Is it something more generic? How can we serve the most people and have impose the least on library authors and core itself, and just like I want a thing that is as generally useful as possible, and as especially like as performant as possible. It's like I want to avoid specifying any backend of this. I want it to be just, like I said, a thing to say, I have some data, here you go. And that can connect to anything. So that should be very little cost on its own. It's whatever that connects to that would be the cost. So yeah. Anyone else have anything to say? Tierney still has his hand up.
Sorry.
But I don't know. Okay.
Yeah, I was just thinking it's almost a little bit unfortunate that this wasn't proposed 5 or 10 years ago, because I think it would have been less debatable, as in we would have landed it by now.
I've proposed essentially the same thing for more than 10 years. They're
Touche.
just, it's more so been a problem of the people that care about observability have been historically a whole fragmented mess of little pockets, and like they're like one of the nice things certainly of OpenTelemetry is that has started to drag them all together, so they actually start talking to each other more now. So we actually have a few more of them in the room today, but yeah.
I'm going to probably tomorrow night at 15. So if you're around tomorrow night. Okay. And then help.
Like we're done.
And we'll probably go out.
Mateo, would you?
Yeah.
Thank you, Stephen.